Well, before I went to sleep yesterday, I wound another coil on the canopy. Um, so there's the new coil, this one, and the other two, and they're all wired in series now. And I was talking previously on the other video, live stream anyway, that I was expecting to get about 3 volts from each canopy section, and eventually when I get all of these coils wired, and I get the other 2 coils wound on here and get them all wired in series, that the total voltage would end up being about 9 volts. Well, it's probably going to be better than 9 volts actually, because with these 3 coils, when this thing gets up to the right speed, will be about 3 volts, because at the moment it's still climbing. We're currently at 2.86 and it's still climbing in speed right now. It's still, the supercapacitor on the motor side is still charging, so we're still going up. Incidentally, because I'm using such thin wire, on the coils, it's 30, what is it, 33 SWG. The actual impedance is quite high. Well, actually, a DC resistance across these 3 coils is 91 ohms, which is pretty high. I really don't want to be that high in impedance, because that limits our output current. But obviously, there's other design adjustments to make. If I improve the rotor coupling, we should get much higher voltages. Now, obviously, if I can get higher voltages, then it compensates for the losses in the impedance, because we can step it down to a low voltage, low current, whatever. But so RPM, I haven't got the meter switched on right now. Just plug this in a minute, switch this on. We're still climbing, 1489, 1490. We're going up in RPM right now. It's got a long way to pick up speed. Now, one of the design quirks, I call it a bit of a quirk, because I realised that my original segment arrangements, which were like that, were actually better, because these segments were overcoming the drag. Well, they were dragging because of the steel, but they were overcoming loaded when the coils are loaded down. They weren't slowing down when I put a load on them. There's 2 possibilities about that: either because the actual steel itself was already effectively creating a load on the system, and that by subtracting that flux energy from the steel, it was making them run more balanced and faster. Now I've got all my steel segments, which I did the different types. There are 2 different types down here, I think. Oh, maybe not on these. Actually, there is somewhere. I don't know where I put them. Oh no, these are all one set. These 6, these 3, and these 3 are all one set. Now, the shielding idea, using the shielding, was a bit of a dead end, really. I was in the process of printing the new segments, and I kind of stopped at that point for a moment, because I realised I needed to. Oh, look, we're at 2.95 right now. We're nearly at 3 volts AC RMS, which is great news. Look at the speed. We're 1500. Yeah, we're doing better than we were. Oh yeah, it's definitely running better. Oh yeah, there was another thing I forgot to mention. I accidentally created a problem I had these bits of steel. I had these met glass. I had a piece of met glass wedged around the back of the coil like on there, and inadvertently I'd shorted out this coil at the end, so this coil wasn't producing enough power. I didn't even notice it at first until I actually wound with this other coil. Then I noticed there was a discrepancy in the voltage, I thought, the impedance. So I measured all the coils, this coil, that coil, and that coil, and that coil was only reading 12 ohms, and that's weird. I thought, that's not right. So I took the met glass out, and it was shorting the coil out. It cut through the insulation of the wire. So that's why I took these out, because they're so friggin' sharp. As I was explaining previously, you can cut your hands on them quite easily. So it caused a short circuit on my coil, so that's not a good idea. I've left that one in for now because it's not shorting anything out, but yeah, that's not ideal. But what I really want to be doing, I want to be shaping the met glass like this anyway, so that it actually goes around. I'm trying not to put my hand on this, so it actually goes around my coils like this. Right, so this is the sort of arrangement that we need, really. It improves the output a lot. If I just stick that on there, you'll see the voltage has gone up to 302 now. Take it off, it's gone up to 2.93 now. So it makes a big improvement, and it also reduces drag, and I'll put that on there. So we're going up to 304, look. So obviously we're not going to reach our peak voltage without these on, because we need to put these on so that they're permanently. What I was going to do is 3D print some plastic slots to stick on the back of the canopy, and then I can just slot the met glass into it rather than gluing them on, because then I can just remove them and put them back on easily, because they vibrate. You can hear it. It's vibrating and it's not exactly secured, and I don't want to keep gluing them on, taking them off. So I'm going to make some 3D printed holders for them. If I get the whole piece, which is not the ideal shape, which is this one, which was on there before, because it's not on there right now, obviously. Stick the whole thing on there. It's probably going to fall off because it's not glued on. Stick this whole thing on. Look at that. 3.31 volts AC. Look at that. So, will it stay on there? That's with it, without holding it. 3.26 volts AC. That's just sitting on the back there. Took it off, and we drop in volts down to 2.92. So you can see the difference that makes. It makes a huge difference. And it doesn't make it slow down, by the way. It actually improves the speed a bit. Look at 1500. Let me just put this on. There's something catching on here, which is what's slowing it down as well. There's something catching somewhere. Right, resting on the back there. 3.32. And look at our RPM. Going up. Slowly, but it's going up. So this is just an update, a quick update. So we're actually increasing the speed of that on. That'll probably fall off because it's not glued on right now. But, so it definitely makes a big improvement. 3.33, still climbing. And when I first wound the new coil, and I was testing this, I was a bit disappointed. I thought, oh, the voltage is not 3 volts, it should be 3 volts. Then I realised I forgot to put the steel, the met glass, sorry, nanocrystalline. I'd forgotten to put it on the back. And obviously when you put that on, you do get the 3 volts, which is what I predicted. So, yeah, pretty good. So working that out, if I have 9 coils on here, and each canopy is at 3.33 or something, we times that by 3, that should give us what, We'll probably end up with 12 volts actually. Yeah, maybe. Let me think. So if we're getting 9, maybe 10 or 11 volts, maybe 10.5 volts. Anyway, that's obviously if this thing is running a bit faster, we'll get 12. But yeah, I was trying to do it with the current settings, you know, the current voltage input and everything. But there's some, yeah, one of the canopies is cycling on me, cycling and catching a bit. Don't know which one it is. The bottom canopy is not wound yet, it's got no coil on it yet, so just a quick update on everything, just to show you that our predictions about the 3 volts on each canopy is definitely going to be there, and the new wire is pretty good, so it's doing what I want it to do. Yeah, I would love to have wound the thicker wire, but there's just no way. I mean, the wire would, if I'd wound the thicker wire, it would be so massive, it would be so far away from the rotor, there would be no coupling on it, so the coupling effect would be just inefficient. So it's better just to work with the thinner wire because I can get more in a smaller area and closely coupled. So yeah, I've got an issue with something catching. I'll sort that out later. It's probably going to go away anyway. Once I wound the coil on all these other canopies, it's probably going to pull the canopy, it's going to shape it out, it's going to pull out the flanges a bit on the edges, it's going to be more outwards, so it's going to be less chance of it catching. Yeah, every time it starts catching I lose RPM. Look, it's dropping right now because it's catching, which is annoying. It's going back up again now. It's cycling on something. It's the harmonics. It's the harmonics that's causing that. Yeah, anyway, that's it. Just a quick update on everything. Okay, bye for now.